Today's PowerPoint is dealing with research methods. We're going to be looking at some pre-research decisions and describing the process of psychological research. In addition, you should be able to name and differentiate between the different types of research methods available. Some of the pre-research decisions that you need to be familiar with include asking questions, deciding on a method, and looking for evidence. No matter what method is being used, you have to take into account what population you will be studying. Population is defined as all the cases in a group from which samples may be drawn for a study. For example, if I was looking at the levels of motivation between junior and senior year at Farmington High School, my population would be all of the juniors and seniors, both male and female, enrolled at Farmington High School. That's my population. If I were to continue using that example to talk about what a sample is, it would be pretty unrealistic for me to make contact with every single junior and senior at Farmington High School. So what I would want to do is draw from the entire population a smaller group of participants that the researcher would then study. I would take maybe half of the junior class and half of the senior class and possibly administer a survey to find out how their motivation changes from junior to senior year. If it were to be considered a representative sample, it would definitely reflect the population being studied. So I could feel pretty certain that the information that I gathered, my data, would fairly reflect all of the juniors and seniors. If it's a non-representative sample, my survey might be skewed. There might be something that leads me to believe that it's not a really good, accurate measure of motivation between junior and senior year. The definition is a sample that unfairly reflects the population being studied. So for a different example, if I were studying the height of American men, I wouldn't want to use all basketball players as part of my sample, because we know that basketball players typically tend to be taller than the average human. One way to ensure a representative sample is by using a random sample. A random sample is a sample that fairly represents the entire population because everyone has an equal chance of being selected or an equal chance of inclusion. For those of you who have taken statistics, you can do a random sample on your calculator and it can grab a random set of numbers for you. If I wanted to use my example of measuring the levels of motivation between junior and senior year, I could go to Miss Chambers in the third floor office. I could have her give me a random sample of, let's say, 250 juniors and 250 seniors. I could hand out a survey, collect my data, and I could feel pretty certain that my random sample of surveys was representative of the entire population. One thing that you have to be careful of is what's called the false consensus effect. It's when we tend to overestimate the extent to which others share our beliefs and behaviors. Remember, we're pretty overconfident people in general, and sometimes we overestimate other people sharing our same beliefs. And researchers have to be careful of this. They can't just take their opinion and their belief system and apply it to the general population. That's why these methods of either surveys, experiments, correlational studies need to be conducted so they can feel very certain that the hypothesis that they have formulated is backed by evidence. One second here. Gotta find my slide that I want to be on again. All right, hang on a second. There we go. Here are the 5 different research methods we're going to be talking about. Naturalistic observations, case studies, surveys, experimental research, as well as correlational research. So your goal is to be able to define each of these research methods and understand where their strengths lie, yet where their weaknesses are also present. So the very first research method I'm going to be describing is called a naturalistic observation. Oftentimes we want to look at human or animal behavior in the environment that they live in. And we want to make sure that their behavior doesn't change because they know they're part of a research study. So naturalistic observations are really nice because you go out into the field, or if a participant comes in, they're unaware that they're being part of a research study, and therefore their behavior doesn't change. Jane Goodall is a really good example of a naturalistic observation. She devoted 30 years of her life studying the chimpanzee population in Tanzania. So she was able to understand their sleeping and eating patterns, their mating rituals, the way they communicate, the hierarchy of their family structure. And she did so by truly living within the jungle in their community. Another way to look at it, however, is sometimes when we have children, let's say developmental psychologists want to study the growth and development of children, and sometimes you see rooms that have a one-way mirror. So the observer can look in and record their observations, yet they go unnoticed. We have one of those in our preschool room here at Farmington High School. So research is conducted in the environment where the behavior usually occurs. The one downside, well, there are a couple downsides to this technique. One is that you're unable to control the events. You simply observe. So unfortunately, if you don't observe the behavior that you're studying, let's say if it were an eating pattern, and while you were watching they didn't eat, that would be a downside to using this study. Another thing is that you really cannot identify the cause of the behavior. Naturalistic observations just allow for you to describe and make predictions, which is very valuable. But in some cases, this might not be the best research method to use, given the nature of what you're studying. Another research method is a case study. This is an observation technique in which a person is studied in depth in hopes of revealing universal principles. Two famous psychologists that used case studies almost exclusively were Sigmund Freud and Jean Piaget. What's nice is you're able to study rare and unusual cases and learn a lot of information, but unfortunately, the generalizability is difficult because usually the rare and unique case doesn't apply to the entire population. But that is the goal, and the hope is that you can reveal universal principles. But a lot of times we just simply gain information about unique cases when you're studying an individual in depth. Another good method, if you're trying to collect a lot of information in a relatively short amount of time, specifically dealing with attitudes and behaviors of people, is using a survey. So when you want to question the individual, you can hand out a survey. You just have to make sure that it is a representative sample. Now, again, one of the flaws of surveys is that sometimes people aren't honest in the survey, so your data might be a little skewed. Or you have to make sure the questions that the person includes in the survey are not leading and are not biased. If you take into consideration that, you oftentimes can get some good results. The other thing you have to be careful of is using a a random sample so that you can guarantee that your survey results do reflect that of the entire population. Correlational research is also another important research method to understand. Oftentimes, psychologists are looking at whether or not behaviors go together, if two factors vary together, and how well they predict one another occurring. So, for example, here you see there's a correlation between our students' grades and how much they sleep. I think you can relate to the fact that the amount of sleep you get directly affects your performance in school. But you have to remember that correlational studies do not show causation. Correlation is not cause and effect. You can see on this slide the word predict is underlined. So correlational studies look at how one variable or one factor might predict an outcome. Correlation does not equal causation. So here on the left, you see how we do oftentimes feel there is a correlation between having breakfast and having a good nutritional start to your day and having good grades. However, we know it's not cause and effect because there are people who do not eat breakfast every day and yet they get A's on their report card. And wouldn't it be nice if we could say, hey, if you eat breakfast every day, you're guaranteed to get good grades. Unfortunately, that's not the case, but we do know that one does predict another. It just isn't cause and effect. So this is an example of showing how correlation does not mean causation. Correlational coefficients are something you need to be familiar with as well. This is a statistical measure of a relationship. So this type of research study does involve numbers and does involve some statistics. Luckily, you don't ever have to figure out correlational coefficient. You just have to look at a set of data and you need to understand whether or not it's showing a strong correlation. So what you see here on this particular slide is the direction of the relationship. It's either positive or negative. If it's positive, you'll see a plus in front of the number. If it's negative, you'll see a minus sign. This number over here indicates the strength of the relationship. What you need to remember is that the closer you get to 1, the stronger the relationship is. So you could have a very strong positive correlation if your number is positive and close to 1. You can see that it's a strong negative correlation if your negative number is close to 1. In this particular illustration, you see a perfect positive correlation here on the left. The green dots measuring upward on the XY axis. You see in the middle no relationship at all. And then on the far right, and with the blue dots, you see a scatter plot showing a perfect negative correlation. Both indicate a perfect positive correlation with the green and a perfect negative correlation with the blue. If you were to ask yourself which of the following correlational coefficients show the strongest relationship, you would find the answer to be what? A, B, C, D, and E. Remember, it doesn't matter if it's positive or it's negative. Which number shows the closest set of numbers to 1? Now, another thing that you have to be familiar with is what's called the illusory correlation. This is a perception of a relationship where none exists, and we see this happen quite a bit in our everyday lives, where you feel that just because two things are close to another, that they mean something, and that isn't always the case. Some examples of illusory correlations are listed right here, like infertile couples who adopt become more likely to conceive, or sugar makes children hyperactive, or getting cold and wet causes one to catch a cold. That isn't necessarily accurate. One doesn't cause the other. Sometimes the examples that we see here are merely coincidence. So we have to be careful of making assumptions that one predicts another in every case. Oftentimes that's what we refer to as an illusory correlation. One of the most important research methods is the experiment. And this is because this is the only research method where you truly can infer cause and effect. And this is really nice because the way we can infer cause and effect is simply controlling the situation. Let me back up again, sorry. So experiments allow the researchers to control the situation and to decrease the possibility that unnoticed outside variables will influence the results. The first terms we see up here are independent variable and dependent variable. What you're supposed to be able to do, ideally, is look at information given a scenario. Can you identify what the experimental factor that's being manipulated is? If you can, that's the independent variable. If